Alright, so we're going to go ahead and get started. I'm trying a new setup, so hopefully the setup will work, and hopefully you can get all the information that you need. Some of you are having to make up your NS1 and 2 tests because of the quarantine stuff, and you've been out, so we're trying to get you caught up. Some of you just kind of struggled with some of it, so I'm going to let you have this video, and then you can go back, watch it. Hopefully whatever areas you are missing out on, we can kind of get you caught up a little bit. So before we even get started looking at the problems, that's essentially what we're going to do. We're going to go through and work 20 problems, but before we even get started with this, I do want to have just like a little quick reminder as to what is rational and irrational numbers. Okay, and this is going to be basically the majority of these questions. So we've got this, and then we have our square roots, and I think possibly our cube roots, but other than that, that's pretty much going to wrap up this lesson. This is one of those objectives that you need to get your average up as high as you possibly can. This is one of those that should be fairly easy for you. So if you have any questions before you take your test, make sure that you come and find me. You ask me those questions in person so we can get it sorted out before you take the test, because you need to do good on this one. Alright, so to start off with, we're basically going to add one word to this irrational column over here, and that's going to be non, or non. We're just going to repeat that over and over again. Alright, so basically whatever a rational number is, if you're looking for the irrational version, it is the non-version of whatever rational is. So, for instance, for rational numbers, we're going to start off with those being a perfect square. Alright, so now all we need to do is, if we know that rational is a perfect square, we're going to come over here and say that irrational is a non-perfect square. Okay, and the way you find this is when you type it into the calculator, and I'll throw it up real quick. Whenever you go to type it into the calculator, if you end up with a square root that has a decimal, that lets you know it's going to be a non-perfect square, which means it falls into the irrational category. Alright, so to start off with, let's do second x squared. I'm going to type in 25 and hit enter. So because I get a whole number 5 with no decimal after it, that means, it's kind of hard to see, so because I get a 5 with no decimal after it, that means it is going to be a rational number. Alright, so if I hit clear, and then I come back and let's do second x squared 27 and hit enter, I'm going to end up with 5.196. So because I have this decimal here after the 5, I know it's not a perfect square, which means it is going to fall into the irrational category. Okay, so for perfect square, I'm going to put in square root of 25. For non-perfect square, going square root of 27. Alright, so if you end up with a decimal, non-perfect square. Alright, speaking of decimals, let's move on to the next one. For rational, we have repeating decimals, and we have terminating decimals. Alright, so if rational is repeating and terminating, that means irrational, draw my little line, is going to be a non-repeat and non-terminate decimal. Okay, the way that you identify these is they're going to have a dot, dot, dot after them. Okay, so essentially if you have like 1.23 with a bar, or you just have 1.23 and it terminates, there's no more numbers after it, no more dots, both of these are going to be considered rational. Okay, the only decimal you're looking for to be irrational is if you have like 1.23 dot, dot, dot. When you see those 3 dots, automatically you know it's non-terminating, non-repeating, and that falls into the irrational category. Alright, let's look at one more big one that they have. Symbol for pi. I don't know why they like to stick it on a test, but they do. Whenever you see that symbol for pi, nothing else matters. It's automatically irrational. And if any part of the problem is irrational, that means the whole thing is going to be irrational. So if they give you 3.14, even though most of us know that as being pi, you have to look at this as a terminating decimal, just like the 1.23. So 3.14 is rational, but when you see this symbol, that's the one that's non-repeating, non-terminating. That's the one that is going to be irrational. Okay. The other thing that some people have some issues with is fractions. If it's just a normal everyday fraction, like 2/3, 1/2, 8/15, for instance, all those normal fractions, they are going to be rational because at some point they are going to terminate or they are going to repeat. However, if I give you part of it that is going to be irrational, such as like 2/3.7 dot, 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 because this part is irrational, that means the whole thing has to be irrational. Alright? Alright, so that's going to be sort of the crash course in rational and irrational, but essentially you're looking for dot, dot, dot on your decimals, you're looking for the symbol for pi, and you're looking for the square root of a non-perfect square. And again, whenever you see that square root sign, I want you to use your calculator. Even if you know it off the top of your head, go ahead and type it in. We're going second x squared over here on the left, and then you type in the number, say for instance 25, and hit enter. If you get a decimal, that means it's irrational. If it's a whole number with no decimal, that means it's rational. Okay, simple enough. Alright, let's start looking through some of these questions that we've got over here. For number one, we've got which one of the following is an irrational number. So in looking at this, we just have to be able to identify all of these and then decide, is it going to be rational or irrational. Alright, so for our first one, we got 17 over 5. That's just a normal everyday fraction. We're going to go ahead and identify that as rational. We have the bars over this one. If it's a repeating decimal, that also means it's going to be what? It's going to be rational. Alright. Over here, we've got the square root of 9. Throw it in your calculator if you don't feel comfortable with it. We've got second x squared 9, enter. It gives us a whole number of 3. So because we end up with a whole number of 3, that means it's going to be rational. Okay. So if we did all this part right, that should take us to answer choice D. Second x squared 3, enter. That's going to give us 1.732. So because this one comes up with a decimal, that means it's not a perfect square. That means it is going to be irrational. Okay. All right, let's slide up and look at number 4 real quick. We got which numbers are going to be irrational. Select all that apply. Pretty much the same question, just given to you in a different way. We have a repeating decimal. Repeating decimal is rational. We have 3.14. So again, even though you know it as the number that is associated with pi, that's the approximate value for pi. It's not the exact value for pi. So we have to look at it as a terminating decimal. That gives us a rational. Alright, square root of 16. Use your calculator if you need to. We got second x squared 16, hit enter. Gives us a whole number 4. So because we get a whole number 4, that is going to be rational. Symbol for pi. Remember on our little cheat sheet over here on the side, anytime you see the symbol for pi, we're going straight up irrational with it. So this one's going to be irrational. Square root of 24. So second x squared 24. Going to give us 4.898. So again, because we come up with a decimal, this one is going to have to be irrational. Okay, and if by this point you do not know your perfect squares, that's something you probably need to work on. So we'll just take a second to look at those. If I go 2 times 2, that's 4. So that means 4 is a perfect square. If I go 3 times 3, I get 9. 9 is a perfect square. 4 times 4 is 16. 16 is a perfect square. So if these are my perfect squares, that means everything in between there, like 5, 6, 7, and 8, none of those are perfect squares. So if you see the square root of 5, it's irrational. Square root of 6, it's irrational. Square root of 7, it's irrational. Same thing with this. If I see 10, 11, 12, 13, 14, or 15, because that is not one of the perfect squares, that means all those are imperfect squares or non-perfect squares, which means they are going to be irrational when you see them. All right. So look at number 3. We got justify whether the square root of 4 is a rational or irrational number. So if we're looking at this one, we have to be able to go through and we have to be able to make a decision on why the square root of 4 is going to be an irrational number. Okay. So in working with this, we have 4 is a rational because it is terminating, 4 is rational because it is repeating, and then we have 4 is irrational and 4 is irrational. All right. Well, here's the thing. If we're looking at the square root of 4, that means it's going to come out to be 2. So we can go ahead and mark off our irrational labels. Now we're going to be focused on our rational labels. Alright? So if I have the square root of 4 is equal to a whole number 2, does that look like a terminating decimal or a repeating decimal? So we're going to end up with 2.0. It cuts off. There's nothing else. So we're going to have to go with answer choice A on that one. Alright? So now let's move on to number 4. We've got drag each number to the left to the correct description on the right. So we're starting off with 4/7. So again, just a normal everyday fraction. It's going to give us a rational. I've got 3.77. Do have a repeating decimal. If it repeats, it's rational. Got the square root of 5. If you need to, type it in your calculator. Second x squared 5, enter. Gives us 2.236. So because I typed it in, because I have a decimal, we're going with irrational. And then finally, the square root of 169, that should come out to be 13. Again, if you need to, especially on the larger numbers, second x squared 169, enter. So that's going to give us a 13, so it is going to be rational. Alright, so on that one we got 3 rational, 1 irrational. Alright, Looking at this, we got number 5. Which number is considered to be an irrational number? So again, the same exact question, it's just giving you more numbers. So we see a repeating decimal, repeating by now, should know that it's going to be rational. Got 0.25 with nothing at the end of it, so that one is terminating. That one has to be rational. On this one, I've got dot, dot, dot. Remember the 3 things we're looking for: the symbol for pi, a non-perfect square, and we're also looking for dot, dot, dot on our decimal. So there's our dot, dot, dot. That's going to be the winner for irrational. And just in case, 3.5, it terminates, so that one's going to be rational. Alright, moving right along. Let's go over to, see if we can get 6 lined up. There we go. Number 6, choose a word from each drop-down menu to make the sentences true. So I've got the decimal form of 17 over 80 when expanded, and the decimal form of 17 over 30 when expanded. So to start with this, I'm just going to type them in. I've got 17, that bar means divide, just like a normal math operation. So 17 divided by 80, I'm going to hit enter. I end up with 0.2125. So in that case, it's going to be a terminating decimal. It stops, it doesn't go anywhere, right? Alright, on my next one, I'm going to have 17 divided by 30. I'm going to hit enter. That gives me 0.5666, whole bunch of sixes. So I'm just going to cut it down to 0.56 repeating. So again, if that 6 is going to repeating, I'm going to circle repeats. Right? So we end up with 1 terminating and 1 repeating. Alright, for number 7, we've got the following numbers are either rational or irrational. So again, same question as before. We've got dot, dot, dot. That's one of our 3 big ones. So we're going to go ahead and label that one irrational. We've got the square root of 64. That's going to turn out to be, if you type it in your calculator, second x squared 64. Should give us a whole number 8 with no repeating after it, no decimals after it, I mean. So that one is going to be rational. 23 over 57, just a normal fraction. No part of this is irrational. So because no part of it is irrational, that gives us a rational. And then finally, we're going to end up with the square root of 51, and we got 7.14. So because we have a decimal when we took the square root, we know that's going to be irrational. So it wants us to compare the two, see which of the above numbers are rational. So that's going to be numbers 2 and 3. So it's looking like our answer choice is going to be C. Alright, let's scroll on up to A and B of number 8. Using information to provide an answer for part A and part B, consider the following irrational or rational numbers. Why is the square root of 20 considered an irrational number? Okay, so the first thing we're going to do, go ahead and type it in. If nothing else, you can get some extra practice. We've got the square root of 20. So that's going to give us 4.47. So because we get a decimal, when we type it in, we do know it's a non-perfect square, and because of that, we also know it is irrational. Okay? So in looking at this, we need to find the one that says it's going to fit the definition of irrational, which says it has to be a non-terminating and non-repeating. So when evaluated, the square root of 20 converts to a repeating decimal. Okay, that one's out. We don't do that because repeating is rational, not irrational. When evaluated, the square root of 20 results in a terminating decimal. All right. So again, if it's terminating, that's the same thing as repeating, which means it's rational, not irrational. That one's off the list. All right. For our next one, when evaluated, the square root of 20 results in a non-terminating and non-repeating decimal. In other words, we get dot, dot, dot at the end of it. So that one, I think that one's going to be our answer. If we look at the last one, when evaluated, the square root of 20 results in a whole number, which is considered an irrational number. Nope, that one's out. Okay. So again, we got to find the definition for an irrational number, which is why non-perfect squares are considered irrational. Alright, looking at part B, we got when 3/7 is converted to a decimal, what type of number results? So again, if you want to change a fraction to a decimal, we just type it in. 3 divided by 7, hit enter, we get 0.428571429. Ooh, this is an interesting one. Alright, so let's look at this. I'm going to write it out real quick. 0.428571429. Alright, big thanks out to all the test makers who try to confuse children, because you're doing an excellent job on this one. Alright, so let's start out with this one. The first thing I want you to do, whenever you have a decimal that's really long, in other words, it takes up the entire screen, I want you to go back and basically try to find some pairs in it, alright, some matches. So I'm going to start off with this one right here. We got a 4. I'm going to scroll across. I got another 4, so I'm going to circle it. Okay. My next number after the 4 is a 2. So I'm going to scroll across until after that 4, what do I see? I see a 2. So those two match. Then I'm going to an 8. So a lot of people, I won't say most, a lot of people when they scroll across, they say that that's an 8, they say that that's a 9, so therefore it doesn't repeat, right? But here's the catch. We have a 5 right here. So by what you know in rounding, this 5 is actually going to push that 8 up to be a 9. So we really have a 4.29 on this side, and if I draw a line there, we've got a 4.29 on that side. So essentially they're trying to use the calculator to mess you up, but if you know that that 9 is really an 8 and is being pushed up by that next number that the calculator cuts off, that's going to let you know that those are in fact repeating decimals. So if they are repeating, that means we find the words with irrational, we mark those off the list, and now that we have our repeating, we know that they're rational. That takes us to our second choice. So they are going to be rational and they are going to be repeating. It just looks a little weird because that 5 is going to push that 8 up to a 9, just like the 5 would push the 8 up to a 9 on the end. Alright, so don't let the test makers confuse you by little details. Number 9. Which decimal is going to be equivalent to 12 over 55? So again, use that calculator. They say you can use it, use it. We got 12 divided by 55. I'm going to hit enter. 0.21818181818. Right? So now we're going to look at this. We're going to write down the number that's not repeating, write down the first two that are repeating, and draw our bar over them. Okay? So now we've got 0.2 and then the 1/8 repeats. So that one's off, that one's off. A. Going backwards, A is going to be our answer. So the 2's by itself and then the 1/8 repeats. Alright? Alright, so when I printed these off, I didn't have print background, so it left some of the numbers off, so we're going to have to skip 10. Let's look at 11. A good old-fashioned word problem that I know everybody loves so much. Alright, we got Jack estimated square root of 75 to fall between 8 and 9. Brenda gave a more precise estimate saying the value is between 8.6 and 8.7. Branson says that he can estimate the value so that it is between two consecutive rational numbers with decimals to the hundreds. So in other words, we're rounding to the hundreds. Between what two consecutive numbers does the square root of 75 lie? Alright, throw up your handy dandy calculator. We're going to do second x squared 75 and enter. Alright, so when we type that in, we've got 8.6602. Really only need to go to the thousands, but I'm going to go one more just to make sure. Right? So now we need to figure out what is that last number going to be. So I've got 8.660, but I am going to have something else that pushes it up. So I have two options, 8.66 and 8.66, but because I know there are some decimals after that, that means it's larger than this 8.66. So that needs to be my lower number, and it's got to be in between these two. So that's going to give me answer choice D. Alright, let's look at number 12. We've got which point shows the approximate location of the square root of 13. So again, we're going to use our calculator. Second x squared 13 gives us 3.605. So 3.6 is the one that we're looking for. If we look down at our number line, we got a 2. We got one that's about halfway in between 3 or 4. We're looking for 3.6. B is going to be our answer. So A would give you a whole value of 2. C would be about 6.5. D, whole value of 13. Alright. Alright, I was trying to keep this about 20 minutes. We're already at 19. Or at least getting closer to the end. Alright, number 13. We got order the following irrational numbers from largest to smallest by dragging each number from the left to its correct position on the right. Okay, so in this case we have to go through and actually work these out and figure out what we come up with as far as the number goes. So one of the good things about the calculator that you're using for the TI-30 is that you actually do have a symbol for pi. So you don't have to approximate it at 3.14, you just hit the button. So I'm going to hit, oops, not twice. I'm going to hit pi and I'm going to divide that by 4 and hit enter. So when I do that, it comes out to be 0.785. Okay. On the next one, square root of 17, we're just doing a normal square root, so second x squared. Going to hit 17 and enter. It's going to give me 4.123. Alright, we got one more to go. This is something that we normally don't do in 8th grade math. This is going to be more of like an Algebra 1 type question. We're going to go ahead and talk about it anyway. So essentially what we're doing is, if in order to have this 2 on the outside, we're actually taking the square root of whatever number's on the inside. So we kind of have to work it backwards. So if I say 2 times 2, that's going to give me a 4, right? So this could be turned into square root of 2 times 4. And then we just multiply those together, we end up with the square root of 8. So I'm going to come up here, and now this part you should be able to work with no problem. Now I've got second x squared 8, hit enter, 2.82. So 2.82. Alright, so now in looking at this, I've got my smallest value, which is 0.785. I've got my middle value, which is 2.82, and I have my largest value, which is 4.123. Alright, let's slide on to number 14. Which statement is true about the values of the square root of 2 and the square root of 6? The value of the square root of 2 and the value of the square root of 6 both fall between 2 and 3. So let's go ahead and work those out, and then we'll look at them. Second x squared 2, by typing it in to your calculator, we end up with 1.41. We'll go to the nearest hundredth. And then I've got second x squared 6, and enter. It gives me 2.45. Alright? So now let's go back and read our choices. The value of the square root of 2 and the value of the square root of 6 both fall between 2 and 3. It's going to be a big old no, because that one's in between 2 and 3, that one not so much, so A is off the list. The value of the square root of 2 and the value of the square root of 6 both fall between 1 and 2. Well, that one falls between 1 and 2, but that one's too large, so B, off the list. The value of the square root of 2 is about one number less than the value of the square root of 6. So if I say 2.45 and I subtract out 1.41, I'm only 4/100ths off. So for now I'm going to circle C. I'm going to check D just in case. The value of the square root of 6 is about one number less than the value of the square root of 2. So they just reversed it. They're saying the square root of 6 is going to be less than the square root of 2. That can't happen. So D's out. Alright. So C is going to be our answer for number 14. For number 15, we've got between which pair of rational numbers does the value of the square root of 59 lie? So again, we're going to come over here, we're just going to type it in. We've got second x squared, 59, enter. So we've got 7.68. So that's the one that we're looking for. And as much as I'd like to tell you there's a shortcut to this, I don't know of one other than just working stuff out. So we got 19 divided by 3 gives me 6.33, and then we've got 20 divided by 3, and that gives me 6.66. So, and those are repeating. So that means it is larger than the first one, but it's not lower than the second one, so that one's out. Alright, so I'm going to say 25 divided by 6. It's going to give me 4.16, repeating, so this could work. And I'm going to say 26 divided by 6. 4.33. So I think we're a little bit low on that last one. That is not larger than 7.6. So B's off the list. 30 divided by 4. 7.5, looking promising. And we've got 31 divided by 4. Hey, 7.75. So 7.68 is in between 7.5 and 7.75. Okay? If you don't like decimals, one of the things that I advise you to do is always go to the hundredth with it, and that way it'll make you hopefully feel like you've got money. So essentially what you're saying is $7.50 and $7.75. Well, in between those you have the $7.68 that you are looking for to begin with. So take it to the nearest hundredth. Everybody understands money. Alright, let's look at number 16. We've got which two irrational numbers fall between 18 and 19 on the number line. So we are going second x squared 350, hit enter. I end up with 18.70, and it is irrational because we have a decimal. It is going to be between 17 and 18. So I'm going to put a little x over it. That one works. Alright, let's come back to these two in just a second. Alright, down here I've got 6 times pi. So I'm going to hit 6 times, and then I'm going to hit the pi symbol, which is the fourth key down on the left, and hit enter. And that one gives me 18.84. So that one's going to be in between 18 and 19. Let's do the last one. We've got pi divided by 6. So So essentially, you already know you're saying 3.14 divided by 6. Neither one of those is going to be greater than that. So we get 0.52, so that one's off the list. All right, coming back up here. We haven't talked about square roots and ninth roots by the time we get to this lesson, but we can go ahead and at least mention it here. So whenever you have something that you're raising to a power, you've got this little key here on the left. Different people call it different things. I like to call it the rooftop key, just because that's how I learned it when I was younger. That's what it reminds me of. It reminds me of a little rooftop. So what I'm going to do in the case of this one, I'm going to say second x squared 5, hit enter, and then I get that as a decimal without hitting anything else, like clearing it or anything that. I'm just immediately going to hit the rooftop key. So now it says answer rooftop. I'm going to type in the number 3 and hit enter. That takes me to 11.18. So that would equal 11.18, all right? Which again is not in between 18 and 19, okay? So let's take a second and look at this one. I'm going to go second x squared 2, hit enter. So that tells me the square root of 2 is going to be 1.4142135562, and then I need to raise that to the 9th power. So again, without hitting anything else, I'm immediately going to hit the rooftop key. I'm going to type in a 9, hit enter, and it gives me 22.62. So 22.62, which again is not in between 18 and 19. All right. Let's look at 17. We got 3 more to go. So if you hung in there this long, you're doing good. On number 17, we got use the number line above, determine which point most accurately portrays the value of the square root of 8. We have point M, N, O, and P. So the first thing I need to do is type in the square root of 8, hit enter, gives me 2.82. So the number that I'm looking for is 2.82. That's going to be less than 1, that's less than 2, that's almost a 3. So whatever that one is, 0.0, that's going to be the winner. And then P is way over here at 8, so it's way off. Number 18, we are going to skip over that one because we don't have the numbers printed out. Number 19, a list of numbers is displayed. To plot the numbers on a number line, which list is ordered from least to greatest? So again, we're trying to go from the smallest value to the largest value. If you've ever heard the expression, you can't compare apples and oranges, this is what we have right here. We've got some apples and we got some oranges. So in order to compare them, we have to put them all in the same terms, which the easiest way to do this is to convert everything over to a decimal. So if you were working this out on paper and this was on the computer, I would say write all 3 of these down. In fact, I'll do it with you. We got square root of 13, 4.1, square root of 26. Let me make sure I'm staying in the frame. And we've got 3.3, oh, and square root of 20. Missed that one. So now we're going to go back and convert all these decimals. So my calculator, second x squared 13, 3.61. We'll round it up. I think it's 3.60, but the 5 pushes it up to 1. All right, I'm going to bring down my 4.1. We've got the square root of 26. It gives me 5.09. All right, and then on my next one, 3.3. Don't have to type anything in. Let's bring it down. But I've got the square root of 20. It's going to give me 4.47. Alright, so when looking at this, now all we have to do is go back and we have to put them in order, just like money. In fact, I'm going to add a 0 to that one and that one. Put them in order from least to greatest. So we need to find the smallest amount of money. So 361, 410, 509, 330, and 447. So my smallest amount is going to be coming in right here at 330. So there's a 3.3, that one's off the list. There's a 3.3, that one's off the list. Alright, let's go to our next lowest amount. Got one more at $3. That matches up with the square root of 13. So that's got 4.1. That's got the square root of 13. So C has to be our answer. If you want to, you can go through and check the rest of them after 361, we've got 410. Then we've got the square root of 20. Then we got the square root of 26. So C is our answer. Alright, last one, number 20. We got the value of the square root of 19 falls between which 2 whole numbers? 1 and 2, 2 and 3, 3 and 4, and 4 and 5. I think you know what I'm going to tell you to do already. Take that calculator, throw it up there. They let you use it, use it. So the square root of 19, enter. It's going to be 4.35. So over here, 4.35 is my answer. That's going to come in between 4 and 5. So that takes care of answer choice D. Alright. Alright, so that was a brief discussion of rational and irrational. At the very beginning, And then we worked through and we worked out 20 different practice problems. But again, the key thing for rational and irrational, look for the irrational first. You're looking for decimals with a dot, dot, dot at the end. You're looking for a non-perfect square, which means it has a decimal whenever you type it in your calculator. And then you're also looking for the symbol for pi. And if any part of it is an irrational number, the whole thing is irrational. All right? So if you have any questions whatsoever, you need to make sure that you just get with me at some point, either before school or during class, and just ask me whatever your question is, and we'll try to get it sorted out before you have to make up this test.